of 300, which means we're multiplying the decimal 0.12 times 300. And this will give me the number 36. Increase 300 by 12%. Well, this is another way of saying 12% of 300. We're going to be multiplying because that's what that word of means. But don't forget, we have to convert the percent to a decimal. Now, we get this 36%. This is the first step in our two-step process. But the second step is taking this 36 and adding it to 300, which means when I finish, I will get 336 as my answer. Now notice the two steps. I find 12% of 300, and then I add my answer, which was 36, to 300. This is the long way. Well, this is where we are going to do a second way. Now, the word increase means add. Well, when we add, we need two numbers to add. Well, unlike the first process, we, because of the word increase, are going to take and add percents. This is taking 100% plus 12%, and we get 112%. Increase means add, so therefore we're taking 100%. Well, you're saying, where did the 100 come from? 300 is considered our whole. And the whole, like an entire pizza, before I eat any slices, is 100%. And then I'm adding, there's the plus, but I'm adding percents this time, which will give me 112. Now, I make 112% a decimal, which is 1.12, and then I multiply this decimal by 300. So if I take 1.12 and multiply by 300, are you going to be surprised that I get 336? Just by the word increase, I take 100% and I add 12 to it. That percent of 112 becomes a decimal. And then 112 times 300 is giving me the same answer I did technically in two steps. And the reason they say this is considered the shorter process is the fact that because I have increase, I know I'm starting with 100%. I'm adding 12 because I'm increasing by 12%. And then 112% because I'm increasing, I'm adding 100 to 12, I will get my same answer. Now, we're going to change it a little bit. Notice that this problem said increase. Well, we got the opposite. We are going to decrease. Now, decrease, we still have a two-step process. Okay, now, the long way, again, is considered two separate steps. Now, this is where you're still following what we did. You are taking 12% of 300, which we learned in the last slide was 36. But decrease means that I'm going to take 300 and subtract 36. Decrease is going down. Down is subtract. And I will get 264. Decrease is subtract. Okay. This is the one step, but this time the second step, because the word says decrease, I got to subtract. Now, the same philosophy. Okay. Now, we are still going to decrease by 12%, but we are starting with 100% and subtracting 12%, which gives us 88%. We're still subtracting, okay? There's my little minus. Subtract. But I have 88%. Well, that means I am going to take 88% of 300. I change 88% to the decimal 0.88 and multiply it by 300. So if I take 0.88 and multiply by 300, are you going to be surprised if I get the same answer as I did on the other side? You've been doing the left side of the last two slides. This is how you've done it. But it's not the same anymore. They're going to start asking you to look at the second way. And we're going to explain why in a second. But there's a couple of story problems that I'm still going to do because you should recall how to do these from past math classes. Now, does it matter which way you do it? No, because we are going to be talking about sales tax and total cost. Now, see this lovely word total? Total means we are adding something, because that's what total means. But you have to know, how is sales tax determined? Well, this is an old problem from prior math classes, but we still give it to you in this section because we want to bring your brain up to date. This is saying the sales tax rate in particular one city of the United States is 8.25%. Now, find the tax charged, and see that little word "and"? This is a two-step process because I have two answers. This is the long way that you've been working up till now. We are going to take 8.25% and make it a decimal. The decimal is 0.0825. Then we multiply 0.0825 by the cost of the product, $680. We are taking 0.85 and we are multiplying it by $680. Now, be very careful. This is money. When you take 0.8, forgot my little zero here. This is 0.825, and you multiply by 680. Now, we can use calculators. This is going to give me 56.1. But remember, this is money. I need to know that this has a zero back here because money has two decimals. Now, this is considered my tax. $56.10 is my tax. Now, this is step 2. The total cost is the sales tax plus the original amount, which means I'm taking $56.10 and I'm adding it to $680. Because remember, total is add. So this will give me 736.10, and that is my answer. Now, this is what we've done all along. Haven't had any problem with that. So, like I said, there's old math problems that you've done in the past, and you should be able to do this section. And then we have discount. Okay. Now, discount means go against the count, which means we are subtracting. Okay. We're going against. Against something is I'm subtracting. Now, This particular table is wanting the discount, which means I'm going to get one number, and then I'm getting the sales price. Well, this problem is still done in 2 steps. Step 1, find 15% of $120 by making 15% a decimal. Then multiply 0.15 times $120. Okay. So if I take 120 and multiply by 0.5, I am getting $18. This is my discount. It is gotten from step 1. Now, notice I haven't subtracted yet. The sales price is where the subtraction comes from. So in step 2, you are taking the original price and subtracting the discount, which sometimes is called the markdown price, to get the sales price. So we are taking $120. We are subtracting $18. And this will give me $102, which happens to be my sales price. Notice sales is the fact that I'm not paying the same amount. Now, marked price is sometimes known as the original price. What you start with, what's on the sales tag. This is old stuff, but we are now going to change this. Because remember, the first 2 slides that we did, I talked about one way. It had 2 steps. The last 2 slides had 2 steps. Well, here is where it comes from. We are going to find an increase or decrease. But when we look at the percent, we are going to make it into what we call a multiplier. A multiplier is a decimal. That is created from the percent. So when they talk about a multiplier, we're talking about a percent. Now, to find the multiplier, you are going to have to use some vocabulary. When you see the word increase, know that increase means to add. We're always taking 100%. Always. And then we add the increased percent. We then have the word decrease. Decrease means to subtract. D, go down. To go down, we subtract. And then we take 100% and subtract the decrease. Now, you're going to notice what they have here as we work through the vocabulary. Notice the instructions. It is saying find the multiplier. Okay, find the multiplier. Okay, that means the multiplier, find the vocabulary word. Well, we have increase. It says increase by 22%. We are taking 100% and adding 22% to get the multiplier of 1.22, the decimal. The multiplier is the decimal, 1.22. Okay. Now, let's look at B. See the word? The word says decrease. Well, we want to find the multiplier. Well, this time we're taking 100% and subtracting 22% to get the multiplier, which is 0.78. Okay, to get the multiplier, we are going to take the answer to this, which is 78%, and we make it a decimal. Number one, the multiplier of 122% is the decimal 1.22. The multiplier is a decimal. Okay, notice multiplier is a decimal. Now, we're going to change this a little bit. Increase by 122%. That means I take 100%. I add 122%. I get 222%. But my multiplier is 2.22. This is my multiplier. Now, some of you may not like D. This says decrease. Well, it's still the same thing. We are taking 100% and we are subtracting 0.22%. Now, I'm going to get a decimal. Okay. Now, this is going to give me 99.78%. But my multiplier is, okay, the multiplier is 0.9978. The multiplier is the decimal. Now remember, 100 minus 0.22 is giving me 99.78. But the multiplier is the decimal, 0.9978. Well, notice the word here, increase. Okay, this is saying 100% plus 222% equals 322%. But my multiplier is 3.22. Okay. Okay. Now, this is how some of your questions are going to be phrased, but you also have this type of question. It says, for a percent increase of 22%, state the multiplier. Okay, do not forget, multiplier is a decimal. Is a decimal. That is crucial. Increase. Well, 100% plus 22% equals 122%. But my multiplier is 1.22, the decimal. Now, same thing for B. It's just another way of rephrasing the question. And it's saying 100%. Now, decrease means minus 36%. Now, this will give me 64%. But my multiplier is 0.64. It is the decimal. Okay. And that's where you have to remember vocabulary. What is the multiplier? The multiplier is a decimal. Now, some of what I've done here you can do in your head, but I'm writing it out for those who need it, because sometimes people have trouble. Now, this is where you have to watch. It says, how do you find the percent increase or decrease for each multiplier? Okay, here we go. To find the increase, we are taking 100% and adding the percent increase and converting it to a decimal. But then what happens if we go for the decrease? We're taking 100% and subtracting. Okay. The percent decrease and converting it to a decimal. Now, what happens if we want to go backwards? Which is what's going to happen. Okay, we are then going backwards. Okay, and this is the second part. See that what this says? It says given a decimal. Well, we're given a percent in these two. But how do you go backwards? Okay. Okay. We are going to go backwards. And that is where the fun goes in. Okay. Okay. Now, I'm going to make this right here. Okay. Given a decimal, if the given a decimal, first make it into a percent. If it is more than 100%, subtract 100% from the newly created percent. Now, given a decimal, some of it's not going to change. We are still going to make whatever we have into a percent. Okay. And as we did above, we are going to be, in this case, if it's less than 100%, we're going to add 100% to the newly created process. Now, these two may not make sense until I show you what we are going to be doing. Okay? Now, let's look here. Okay, I have the decimal this time. Each one of these problems is a decimal. Now, I have 1.37. Step 1, make into a percent. Okay, well, by making it into a percent, I now have 137%. Okay. I am going to subtract 100% to get a 37% increase. Okay. I'm getting a 30% increase because this percentage, 135, is more than 100%. It's more than 100%. Now, here comes B. And as I said, you may not understand what the words were in the last slide, but hopefully this will help you. We are going to make into a percent. This is 63%. Okay. Now, we are taking 63%. 63%, and we're going to subtract 100%. Well, notice this is giving me a negative 37%. But this is where we have to interpret. Remember? Interpret. Negative is saying I have a 37% decrease. This is where we put everything together. We're taking 63% and we're subtracting it from 100% to get a negative 37%. But what does that negative mean? It means a decrease of 37%. Okay, let's go again. Okay, 1.037 is the percent, okay, of 103.7%. Now, take 103.7% and subtract 100%. We get a 3.7% increase because we have a positive number. Now, here we go. 0.963 is 96.3%. Now, right away, notice that 96 is less than 100. Because it's less than 100, I am taking 96.3% minus 100%. Now, I am going to get a negative, okay, 3.7%, or a decrease of 3.7%. A decrease. I'm getting a negative number. Because I get a negative number, I have to translate. What does that word negative mean? Now, E should be pretty easy. 237 is 237%. So I take 230%, subtract 100%, and I get 137% increase because it's a positive number. Okay? I'm still subtracting. I'm going backwards. But there's a catch with this. Because I'm subtracting in B, in D, I get negative percentages. But what do those negative percentages mean? Okay? Okay, now, here comes the story problems. And there is a specific setup that they are going to be doing. Now, to apply a percent increase, or a percent decrease in a story problem. Now, you have to recognize that I am going to have this symbol in the story. I am either going to have an increase word or a decrease word, and this should be decrease. Okay. And these particular equations are pretty well standard. 100% of the original amount. Now, this can be what's on the sales ticket. The story problem is going to tell me I have an increased price or percent. Then I'm going to take the original price and I'm going to take and find the multiplier. The original price will multiply by the multiplier. And we remember how to get the multiplier. Okay. To find the decrease, I am going to take the 100% of the original amount, and I am going to subtract the decrease percent, and then the original amount is going to be multiplied by the multiplier. Okay. Now, these particular problems can have a time element to it. But be careful. You've got to have this symbol in the story problem. Now, if we don't have that symbol, there's a different way to solve it. And we will be talking about that shortly. Now, here comes the story problem. A company's executives expect, okay, here it comes, a 2% increase in sales in the upcoming year. If the company had 62,000 in last year, what do they expect in the following year? Okay, keep in mind, we want the original amount plus the percent increase written as a multiplier. So what we get is $62,000 plus. Now, this is where you gotta be careful. Percent increase. This is taking what we've done. We're taking 62, let's see here, I'm going to erase this. Okay. Take me back. Okay. Now, here's what we want. And let's see, it's probably easier to do this. Yes. Okay. Now, we're told that we have a 2% increase. Okay, right away, we have 100% plus 2% equals 102%, which becomes 1.02. This is our multiplier. Remember that lovely word? This is our multiplier. Now, take 62,000 and multiply it by 1.02. And you will get $63,240. This is what's going to be gotten the following year. And if they want an increase, you know that it's got to be more than 62,000. 62,000 times the multiplier times the multiplier. Okay. Well, let's look at the next story problem. Now, this says, and they're giving you a little clue, we're applying a percent decrease. Notice the word drop. Okay. Drop. Okay. Well, the story problem says the average price of a gallon of milk is $2.79, and it is expected to drop 4% in the next year. What will be the average price in 1 year? The drop, take 100%, subtract 4% to get 96%. This becomes the multiplier, 0.96. This is our multiplier. Now take $2.79 and multiply it by 0.96. Now, I am going to get a lot of decimals. I'm going to get 2.6784. But remember, this is money. Money has to be only 2 places. So therefore, this 8 is going to make my answer $2.68. That's my answer. Okay. Any question? I hope not. Watch the words. Now, this is where we have a difference. Notice that this problem has a percent in the story. Well, what happens if I don't have a percent? That's what the remainder of this section is going to talk about. Finding a percent of change when you don't have a percent in the problem. This is a specific setup, okay? Now, the percent of change is a fraction. Time is always part of this problem. Okay, here we go. The percent of change. The percent of change is going to be a specific fraction. It is going to be larger number minus smaller number. and then it is divided by the original amount, or the amount that comes first in time. Now, this part is going to give you a decimal. But remember, you have to make it a percent. Move decimal 2 places right. It's a fraction. It's the larger number minus the smaller number. Now, this part at the bottom, by the original amount, or the amount that comes first in time. And this is where the next couple of slides are going to be critical. Now, this is asking you for a percent of change. Now, if you look at this slide, there is no place that you see this symbol. Well, that should tell you that I have that new formula. Now, I'm going to have to read what I have here, and they also give me a table to read. But let's read the story, and then there's a couple of things I need to tell you. The ticket price for a one-day admission has steadily increased each year. Okay, we're talking about increased each year at many theme parks, including Disneyland in Anaheim, California. Now we're using this graph. It's got some information. Now notice, this problem says, by what percent? That's saying my answer had better be in a percent form. So the decimal has to be converted. But now, you've got to be careful. This has an element of time. We are going from and to. Okay, in 1985, this is the price. In 1995, this is the price. Well, this is my fraction. I am taking 31 minus 16.50. But what came first in time? 1985 came first, which means this fraction is 1650. So we do the top. 31 minus 1650 is giving me 14.5, and I'm dividing it by 1650. Now I'm getting a decimal. This decimal is 0.8787. Now notice it's going to continue. But I have to know to move this decimal place. This decimal is moving here. Now, this 8, okay, so this is 87.8. Now, they may, because this is money, ask you to round off this 7, because remember it's 8787. But remember, I've got to have a percent symbol. 0.87878787. Move the decimal. I get 87.8. Now 0.8 can be, or 0.9 can be an answer. But because I have 2 decimal places here, they are going to be looking for, and that's Pearson, 2 decimal places here. 1650 has 2 decimal places. That means I need 2 decimal places in my answer. These are called significant digits. Okay. Now, watch what we have here. Okay. Now, this is saying the ticket price for a one-day affair, except this time they're changing the numbers. We're going from 1995, which is right here, to 2005, which is right here. Okay, this is set up specifically because there is no percent. And remember, I want to find a percent, which means this is 56 minus 31. But remember, what came first in time was 31. So therefore, this is 25. I subtract over 31, and I'm dividing by 31. Now again, I'm getting a decimal that says 0.8065. Now remember, this has 2 decimal places. So therefore, this decimal moves 2 places. So my answer is going to be 80.65%. This 5 is affecting the 4. And I need 2 decimal places because there's one part, even though I'm not using it in this problem, it still has 2 decimal places for money. So therefore, 80.65 is what I'm looking at. Okay. Now, here we go. Again, this is saying 2005. Okay, that's right here. 2015, which is here. And remember, I do not have this symbol, which means I've got to make it a percent, which means this is 99 minus 56. Now the key is from. From is my denominator. Find that lovely word from. And when I take 99 and subtract 56, I am getting 43 over 56. When I divide 43 by 56, I get the decimal 0.76785. Well, remember, this $16.50 is not part of the calculations in this problem, but it is part of the story. So therefore, I am moving this decimal 2 places, which means I will get 76.79%. Okay. Now, here we go. Now, this one gets a little more interesting. It says in 2020, which is not on my graph, Disneyland launched a new ticket pricing structure in which the price for a one-day ticket ranged from $104 to $54 to $154. There's a range. Now it says, calculate the percent change for each of these prices. For each of these prices. Okay, this is where it gets a little interesting because I have to do it 2 times. Now, all we have is 99. Well, we're going to do the lower end, which is 104 minus 99 divided by 99. Then we're going to do 154 minus 99 over 99. Each one has to be done because see, for each, there's 2 answers. We have a low end, we have a high end. Now, they're not telling us why they structured the prices differently. It could be that you pay $154 if you come in at 8 o'clock in the morning, and if you come in at 6 o'clock at night, you pay $104. We don't know, but we're told we now have a range. Well, when I take 104 minus 99 and subtract 99, remember, I've got to make my answer into a decimal. Now, this one is giving me 5.05%. 109 minus 99, get that answer, divide by 99, and the decimal I see, I make into a percent. Well, if I take 154, subtract 99, get an answer, divide by 99, I am getting a 55.56%. I get a range. I have 2 different percentages. Okay. Now, last question for this one. Now, it says, use your answers from part D. Okay, I'm using my answers from part D, okay, to forecast the ticket price for the highest tier ticket. Well, the highest tier ticket was the one that was for $154. That was the higher ticket. Now remember, this is a 55.56% increase. That's what D just told us. We had a 55.56% increase for the higher tier, and the higher tier was $154. Now, how do we forecast? Well, this is where you got to really understand, what does this mean? This means that I am taking the higher tier, which is $154, and I'm multiplying by 55.56% increase, which is 100.56% increase. Okay, notice we took that 55.56 and we added 100 to it. That gave me this number. But remember, I got to make this into a multiplier. So it's 154 times 0.15556, which will give me $239.56. Okay. And let's make sure I got multiplied right. 154 times. Oop, I put the decimal in the wrong place. Get me. Okay. This should be 1.5556. Okay, 239.56. So in 2025, it's going to cost me $239.56 just to go to Disneyland at the higher tier. That's a lot of money. But that's what I'm getting. Okay. Okay. Well, we only have a couple more slides, and this is one that I've got to work with you with. Now, this particular slide is another type of story problem. Okay. You're going to need to follow this exactly because the next 4 slides all come together and they're all based on this table. Now, it says, looking at the real world situation, complete the table for each salary and raise option. Now, this particular story is going to be talking about 2 different options in negotiations for salary increases. Now, this is saying we're going to add 1,000 and increase by 2.5%. Okay, let me show you what I'm going to do. I'm going to take the $10,000 and I'm going to add $1,000 to it. This will give me $11,000. Now, I then am going to take my $11,000 and multiply it by the multiplier. Increase by 2.5% is an increase, okay? Because remember, I'm increasing. So this is going to give me 102.5% or 1.025. This will give me $11,275. I'm taking 10,000. I'm adding 1,000. That gives me $11,000. I take the 11,000 and I multiply by the multiplier. I'm increasing by 1.025%. Now, I'm going to do that for each one of these, except I'm going to kind of shortcut a little bit. If I have 20,000 and I add 1,000 to it, I get 21,000 times my multiplier, which will give me $21,525. Then I have $31,000. I'm multiplying by my multiplier to get $31,775. And then I'm taking 40. I'm adding 1,000, and then I'm multiplying by 1.02 to get 42,025. And then I take 50,000, add 1,000 to 50,000, and multiply by my multiplier. I get $52,275. Okay, I'm doing some of this in my head. I'm adding 1,000 to whatever number's the salary. But what I want to look at is right here. 11,000, 21, here, here, here. Those are my calculations. Those should be the answers in that column. Now, we got to do column B, but this is slightly different. Now, this is saying I'm taking $10,000 and I am multiplying first and then adding $1,000. Well, if I take 10,000 and multiply by my multiplier of 1.025, I am going to get $11,250. I'm taking the number and I'm multiplying first, then I'm adding. Now, as I do that for the next rows, this is going to give me $21,500. Okay. Oh, that's going to go here. Okay, that's here. Okay, well, this time I'm going to take 30,000, and when I add them together, I get 31,750. That goes here. This one is 40,000, and what I'm going to get is $42,000. And then the last one if I take 50,000 and then multiply by my multiplier, my final answer is going to give me 52,250. This is what these are saying. So therefore, this column has these yellow numbers. I'm showing you how to get those numbers because they're not going to always ask you how to get those numbers. They're just going to ask you to complete the table. Now, here comes a little piece. Now, if you look at the numbers in the first column and you look at the numbers that I have highlighted in the second column, does the results in the table indicate that the order of the two increases matter? Well, the answer is yes, because column 1 gives higher salaries because the percent increase is being applied to the highest amount. Okay? We are already getting 11,000 on our first line in column A. And it is that 11,000 that I get 11,275. But if I do it the other way, notice I'm getting $25 less. Order matters. Now, here comes the part where they ask you to fill this in. They said, write a formula for computing the new salary if the 1,000 is added first and the new total is increased by 2.5%. Now, here's how it goes. This is how we write the new equation or formula. Now, we are taking the salary, because that's what X is. We're adding 1,000. And then it is this answer that we're multiplying by the multiplier. This is how we compute the new salary. We add first, and then the answer is multiplied. Now, watch how this changes. Write the formula for computing the new salary if the salary is first increased. Okay, first increased by the percent. Well, remember what we did? I kind of did it for you and wrote it there. What we're going to do is take the salary and we're going to multiply it by 1.025, and then we add the $1,000. This is done first, and then we add. Now, last slide of this PowerPoint. Using the information from the previous 3 slides, if these pay structures were offered at your company, now this is where the catch comes in. Which order would management prefer if they were concerned primarily with keeping employees' salaries low? And then the second question, which would the employees want? Okay, here's how the answer goes. Management would want the 2% would want the percent increase on the old salary and then add the $1,000, which is column B. Whereas the employees would want to add the $1,000 to their old salary and then get the percent increase on this new salary, which is column A. That's where you have to remember, if you are a union representative and you are thinking of a lot of people, understand how the company is presenting your salary increase. Are they going to give you $1,000 more plus an increase? Or are they going to give you the increase and then add 1,000 to it? Not the same as you saw in this table. Notice, if I add the 1,000 and then give you the increase, I have higher amounts. I get more money. But management is going to like the second column. They're keeping salaries low, but they're still telling you they're giving you an increase with a bonus. And that's how they sometimes put it, with a bonus of $1,000. Well, technically, give me the bonus first and then give me the increase on my new salary plus the bonus. So keep this in mind. This is how we look at these two. Management wants column B, okay? And column B is lower. Column A is what the employees want. But as an employee union rep, you need to know what the management is offering and how they are offering it. So with that said, this ends this slide. Enjoy.